Welcome to lecture number 10 and chapter number 10, Shell Scripting. So typical agenda that we'll be following today. First, I'll be summarizing last lecture and chapter in review. Then I'll be getting into the objectives of this particular lecture and chapter. Then I'll get into the lecture itself and I'll summarize with some review questions. So the last lecture, what we talked about is we talked about different types of controls. So we really talked about the different types of controls that systems administrators can go ahead and implement within their organization to help protect against different types of threats that may come into their organization. And we've talked many times about the different types of threats that exist within cyberspace, whether it be mass malware and intruder threats, intruder or insider threats and that type of thing. We talked about the different types of mechanisms that are available for systems administrators and information security professionals to start to block these types of threats to make sure that their assets are being maintained, the confidentiality, integrity, and availability of their assets are being preserved. So we talked specifically about password management, access control lists, firewalls and their capabilities, intrusion detection / prevention systems, patching operating systems and their applications, and endpoint protection. In this particular lecture, we're going to get out of the InfoSec model, out of the controls and the threats and vulnerabilities and all those types of things, and really start to get back into the systems administration side of things. So now we have a good understanding in terms of what are the different types of controls that systems administrators can start to do. But remember that they oftentimes operate in a very large organization. So they need to have the ability to automate some of those tasks. And specifically what we're going to be talking about in this particular lecture is what's called scripting. And we'll talk in particular about bash shell scripting. And scripting is a very powerful way, very simple and very powerful way for a systems administrator and for you to start to automate certain tasks within your organization. Now, why do we care about automation? We care about automation because it helps you in terms of speeding up tasks, improving efficiency, improving the effectiveness, reducing the amounts of errors that you may have in performing tasks and that type of thing. So if we talk about bash shell scripting, we'll talk about common programming elements such as variables, loops, and so on. And for those of you who have not programmed before, this may be a lot of new content, but I'll also provide some additional resources for you to kind of learn shell scripting a little bit more in depth. We'll talk about how we can go ahead and handle user interactions and some of the common Unix tools to parse and manipulate text files. So let's go ahead and recall what systems administration is. So systems administration is a set of functions that provide support systems, ensures reliable operations, promotes efficient use of the system, and ensures that the prescribed service quality objectives are met. And systems administration functions include installation, configuration, and maintenance of network equipment and computer systems. So for example, network equipment could be switches, routers, DHCP, DNS servers, and so on, whereas computer systems could be databases, email servers, ERP, and others. And remember that systems administrators are often the first line of defense for all three dimensions of the CIA triad. For confidentiality, they use the appropriate file permissions, so who can access the proper files. We talked about access control lists and those types of things, and you have some hands-on experience from your assignment on how to execute these tasks. And this is to ensure that unauthorized people cannot read or copy transcripts. Integrity is ensuring the quality of data and information being stored is maintained. And availability is the ability to anticipate / prevent failures from affecting end users. You want to make sure that you can access your computer and resources appropriately and properly. So some of the common tasks that are performed by systems administrators include installation, configuration, access control, user management, monitoring, and updating. So these are all of the different tasks that systems administrators typically perform on their job. Now remember that oftentimes there are numerous computers within an organization, and going through all of them individually to execute tasks can be very time consuming. So having a single person go through all of the computers to say update permissions on them can be very time consuming, or remove a particular file on a machine across 1,000 machines in an organization. You don't want to be doing those types of things manually. The reason why, it's very inefficient and time is money. One of the most expensive assets that an organization has is actually people. People, you have to pay their salaries and so on. So if you have a machine or some sort of a task that can be automated, or a machine that can automate tasks, that's very, very useful. And the general principle, and this is something that was taught to me by my mentor, Dr. Chen at the University of Arizona, is that any task which is done manually by a human on a computer can be automated. You just have to find the right program to do it. So what we're going to be talking about is something called shell scripts. And this is in the context of Unix/Linux operating systems. But it's now also available in Windows. So shell scripts are used for automating processes throughout a computer. And the basic knowledge of shell scripting is necessary for all systems administrators. And it's traditionally on Unix systems, now it's also on Windows as well. So you can think about PowerShell, for example. So what we're going to be talking about is examples of common structures and procedures used in all shell scripts. And we're going to combine some of these common elements. Now, I'm not going to be going into the VM and actually typing up shell scripts for you. That's going to take a lot of time throughout the lecture. But rather what I'm going to do is I'm going to have some examples of shell scripts and walk you through the major components of them. I'll also provide some of the mechanisms that you can use within shell scripting to automate tasks. And I'll give you some examples on which these tasks would actually be useful. So the goal is to demonstrate the automation of processes that would be too time-consuming to do manually or need to be repeated in the future. A script versus a program. So for those of you who are wondering what's the difference between a script and a program, scripts don't have to be compiled into a binary file to be run. So say a program that you have on your computer that you go ahead and double click and then you start to open up and interact with it. That's some sort of a binary file that has been compiled that you can go ahead and interact with. Scripts are interpreted and converted into the necessary binary code at runtime. So don't worry too much about these details. Finally, the concepts that I'm going to be teaching you in this particular lecture are not just limited to shell scripting, but it can also be used in other popular languages such as PHP, Python, Ruby, and so on. And each of these languages have their own syntax associated with them. However, the same basic idea of, say, loops or variables or conditional statements and those types of things are all going to be prevalent across all of the different types of scripting languages that exist. So let's jump right into what scripts look like. So we have a script here, right here. And I don't want you to get overwhelmed by this right here, okay? You see that there's a bunch of commands, and these commands should actually look very familiar to you based off of the work that you've been doing in the VM. So making directories, copying, and so on. So what we've got here, if we break it down, is that if we look at this particular, the prompt, so we can see cat/ops/book/chapter 11/backup v1. What we can see is that this is the particular file that we're accessing is called the backup v1. So now we're in that particular backup v1 file. And this file has a bunch of shell commands in it. And these shell commands, the first one is make a directory in the temp directory, or create a folder in the temp directory to save a backup file. Then we're going to go ahead and copy Alice's work into the subfolder. So the subfolder is going to be the backups right here. So we're copying Alice's work into backups. Then we're going to navigate into the backups folder right here, and then we're going to zip up all of the contents. So we're going to backup.zip, and we're going to make sure that it's all zipped up, and we're going to remove the subfolder right here. And then after this is done, we're going to be able to get a confirmation from the system saying that done backing up the work directory. And so the net result of what we've got is that we've got the contents of home/alice/work backed up as temp/backup/backup.zip. Now, the interesting thing is that we can go ahead and type up all of these commands, but imagine that you're actually Alice, right? And you want to go ahead and back up your files on a day-to-day basis. Would you rather type all of these commands in one by one and then have it execute, or would you rather have one file that you execute that file, and that file will actually perform all of these tasks in a sequence, just like what you've scripted it here? The answer should be the second one, and the reason for that is because the first one, you may make an error when you're backing up the files. It may be very cumbersome. It could take a lot of time. Those are all issues that you could face when you're performing this particular task over and over and over again. And backups is definitely a type of control that a lot of systems administrators are going to want to make sure that they have, just to make sure that they have the integrity and availability of data available for their end users or consumers on the network. So what you can do is that you can actually develop this as a script, which is exactly what's happened here. And every time you want to call the script or every time you want to back up your files, what will happen is that all you have to do is type in this command, bash/opt/book/chapter11/backup v1. Really just bash the file name, wherever the file name is located. You got to provide that absolute path. And then what will happen is that the file will actually execute, and all of these steps will automatically execute. You don't have to retype everything, and everything will happen automatically, and you will have a backup for Alice every single day. And then you can go up to the backups file or backups folder and see all of the backups accordingly. So we can confirm the successful execution of the script and so on. So this is an automated task. You go ahead and automate the entire thing. So instead of typing in each of these commands manually, you automate the whole process such that you're able to conduct backups whenever you feel is necessary. So, like I said, what we accomplished here is that we could have simply executed a series of commands to achieve these results, but that's time consuming. So why would we want to create a separate file, save the file, etc.? So the benefits of running a script like this is that next time we just have to run one command. It's very simple. And we don't need to type in all of the 6 commands. So the command is bash, whatever the path is, the absolute path, and then the file name. Now, what we can do is that this is actually a very, very, very simple script right here. What we can do is that we can simply have this script, and it's a very simple type of script that will allow us to execute these particular tasks. But we can actually make what's called the user interface of the script better. And so what we can do is that we can add at the top of the script what's called the hash !bin/bash. And what that's called is a shebang for hashbang. So now you don't actually even have to type in the word bash anymore. The script becomes a command. So backup _v2. So opt/book/chapter11/backup v2. Now it tells you that you're backing up the work directory. You don't even have to type in bash. So you just add this into the top of the script. Now let's go ahead and start talking about what are the different components that you can put into a script. So what we mentioned up here is we talked about those different commands. All of these commands we've been running throughout the course. So we've been making new directories and copying and changing directories and removing and all of these different activities, right? But those are some of the more basic things that you can do. You can actually get quite complex with the way that you operate these types of scripts. So they become very, very useful. So what are the different types of tools that you have at your disposal? And we're going to be talking about several of them. One of the most useful ones is what's called comments. Any line that starts with a pound sign starts with a hash. And it's ignored by the bash interpreter as a comment. Now, what exactly is a comment? A comment is something that the programmer or whoever is writing that particular script puts in to let readers know what the script is doing. It provides additional details that's not part of the programming language syntax that allows the script to be actually interpretable by other people. So it's a form of documentation. So it helps to document how the script works and so on. In my own research, I develop artificial intelligence algorithms, and in those scripts, I start to document how those things work. Number one, so that other people can read them, so if they want to read them. But number two, I could be working on many different things. I may not have gotten back to my programming language for a while, and when I go back to the scripts that I've developed, I have comments in there about how it operates, so I can start to modify it accordingly. So I can put in things such as authors, last modification date, and so on and so forth. I can also go ahead and start to execute permissions on there. So chmod 555 backup v2, so this is going back to the actual command line, right? Creates a brand new custom application. So let's take a look at that script again. So this was a script up here before, just a series of comments, right? And then we can go ahead and type in bash and then that particular script, and it'll go ahead and execute that particular script. Now we can go ahead and have the hash shebang /bin/bash, and that's going to be at the top. So now we don't even have to type in bash into the interpreter. What we can go ahead and do is just type in that file name, and it'll execute automatically, because the bash interpreter knows to run anything that has the /bin/bash at the top. So we have the comments below. So the hash, this is a comment. Hash, line starting with a pound sign, hash, are ignored in bash scripts. So these are all different types of comments. Now, typically what you'd want to do as a programmer is that you want to make sure that you comment your code appropriately so that it is documented and so on. Now, the top of each program, what you can do, or each script, is that what you can do is you can have a few lines or comments that summarizes exactly what this particular script does. So it becomes very readable. This is in pure English right here, or not pure English, but mostly English. The script copies and compresses files in this particular directory and saves them to this directory. And you can see the different steps within this particular script. So anybody who reads the script can go ahead and understand it pretty easily what this script is aiming to do. So that's in terms of comments. Now I'm going to keep going into different mechanisms that you can start to include in your scripting. Output piping is one of them, and this goes along with the concept of mini scripts. It's an alternate way to write quick scripts. So scripts perform a certain task, automate a particular task. The pipe will allow you to actually execute multiple or write quick scripts. So, for example, now the pipe operator, it took me a while to find it on the keyboard. I don't want you to go through that kind of hassle. If you're on a Windows machine, what you'll find is that the pipe operator, you'll have to press Shift, and it's a button above the Enter key on your keyboard. So what we can see here is that if we type in ls space -l space /user/bin pipe grep gnome pipe head 3, what we can do is that the output of the ls command is sent as input to the grep command. So you can actually run multiple scripts back to back. So the output of the grep command is sent as input to the head command. So you're going ahead and actually running multiple scripts or running multiple commands side by side with this pipe operator. And out of the head command is what is shown in the particular the screen. So you can actually see, if you understand the different scripts or different components of your operating system, you can start to link things back to back. Where does this become useful for a systems administrator? In deploying controls. So if you want to deploy multiple controls back to back, you can actually feed, say, a user access list, right? What types of resources do users have access to? Feed that into another mechanism, another control that actually provides those permissions accordingly, and then provide you an output of who actually gets access to what, right? So those are the different things that you can do. You can start to script it in a way that things link together accordingly. So what if you want to save this output as a file? In a couple of assignments ago, we started to talk about the redirection operator. So the redirection operator is something that looks like this. It's the greater than sign, and then colon, creates file and writes output, and then greater than sign, colon, appends output to the end of file. So this is a mechanism that you can use to go ahead and redirect the output accordingly, or go ahead and save the output to a particular file. Now, where does this become useful? It becomes useful, say, that you actually pass in those particular controls. You have the user access list, for example, right? And then you go ahead and feed that into who gets access to what exactly, and then you want a printout of that, and you want to show that printout to other systems administrators. You can go ahead and have that printout saved as another file, and then that file could actually be used for other system administrators to look at and get an idea of what tasks you ran accordingly. So you can see this particular example right here. So what we're going ahead and doing is that we're redirecting the output to this particular file. And then if we look at that particular file, we can start to see all of the contents within it of the outputs that we have gotten from the previous commands. Now, the general Unix shell script philosophy, why was I showing that to you? So if we take a step back, actually, now we have the idea of shell scripting. Why is shell scripting important? Why do we care about shell scripting? It's the ability to automate tasks. That's very, very important. And then automating tasks can help reduce the amount of errors that a system administrator can make. It can help reduce this amount of time that they spend writing different commands and that type of thing. We have the general idea of what a bash script will look like, so we can go ahead and see a bunch of commands in a particular file. We can go ahead and run those commands in sequence all automatically without having to type everything in one by one. We can go ahead and type in the shebang /bash bin. We know all of that now, right? So we can actually write very long scripts just doing something like this, and we have the ability to pipe it as well. So we go ahead and have multiple scripts running side by side. But the way that becomes useful is that the general Unix shell script philosophy is that you want to use multiple small programs in sequence instead of using a single complex application. And Doug McElroy, the developer of the I/O redirection system in Unix, says that this is the Unix philosophy. Write programs that do one thing and do it well. Write programs that work together. Write programs to handle text streams because that is the universal interface. It's forgotten about in the desktop software world, but reintroduced in mobile and cloud apps. So you really want to make sure that whenever you're developing scripts, it's performing a particular task. You don't want to have scripts that are, thousands of lines long that are doing multiple things. In my own research, I actually typically use smaller, shorter scripts. And the reason for that is because if there's an error in it, if you update the entire operating system and there's parts of your code breaks or whatever, right? What you can do is you can start to debug a lot more efficiently. You can start to look through scripts and get through them much more quickly. And if you know which scripts do what, then you can go ahead and go to those scripts particularly. And they become a lot more readable, and they become less intimidating, and they can feed into others. It becomes a lot more modular and so on. So it becomes very easy to manage in that situation. Now with text manipulation, what we're trying to do is we're looking at different text files or text streams, and we're trying to use and manipulate those text streams within our scripting activities. Now, where this becomes useful is that oftentimes we're going to be looking at what are called log files that are generated from databases, intrusion prevention systems, detection systems, and that type of thing to do, say, anomaly detection and so on and so forth, to identify whether or not people are accessing the appropriate resources and so on. So text manipulation, you want to make sure that you have a good understanding on how to execute these tasks within the context of scripting. Because with text, it become, the types of text that could come from systems are very voluminous. There could be thousands of text files that are being generated, thousands of log files that are being generated, and you want the ability to be able to sift through those very effectively. The previous scripts we saw looked at just backing up files, right? But we also want to be able to go into files as well, thousands of files across different types of systems and so on, and be able to manipulate the text accordingly. Now, the basic tasks that we're going to be looking at are, say, cut, sort, unique, and TR. So cut deals with columnar data with some form of separator. So for example, tabs, commas, spaces to delimit each column in the data set. Sort will sort the lines in a text file. Unique and TR are other types of manipulation techniques that you could use for text when you're sifting through large amounts of text files. So let's get into each one of them accordingly. The cut command parse each line of the data file and extract only the column that you need. So what you're looking at is that instead of looking at all of the rows or looking at all of the data within your within a particular file, where you're going to be looking at is only going to be looking at certain columns. So we did that Excel spreadsheet assignment earlier on in the class. say that you didn't actually want to look at all of the columns within that particular file. What you can do is just cut. You can go ahead and look at a specific column within that particular file. So let's take a look at an example right here. So we have head space -3 space opt book chapter 11 users.csv. So we're accessing this particular CSV file. And CSV, for those of you who don't know, is comma separated values. So each of the values within this particular file is separated by a comma. So first name, last name, username, and then their particular email address. So these are the different columns that are in this particular CSV file. So 1, 2, 3, 4. Now let's say that we didn't actually want to get access to the first 3 columns, for example. What we can do is run a command called cut space -d comma space -F4, so the 4th column of this particular file. So all we'll be getting back is all of the rows, these are the 3 rows, but we're only going to get the 4th column of that row. So we know exactly what we want to access, so we don't bring back everything. Now where does this become useful? Remember, with the piping operators, you can actually use this as input into another script that will do another task. So for example, if you have new employees that have been brought into an organization, right, and all you need is their username or their email address in order to put them on a particular mailing list, right? So the first script could just look inside of an Excel spreadsheet or a CSV file that has all of their information. Then you cut that particular column that you need out and you feed that into another script, and what that other script will do will add them onto the mailing list as needed. So what you can do with cut is that you could actually go ahead and return multiple columns as well. So cut space -d comma and then space -F1 comma 2 comma 4. So we're actually getting the 2nd column and we're getting the 4th column as well. And then we use the pipe operator to go ahead and filter the output with grep. So we search the lines with the string John. So what we did is that once we went ahead and got the columns that we were interested in, specifically the 2nd and the 4th one, we wanted to filter it out a little bit further. We only wanted to look for the ones that had John in there. And then this brought up all of the records that have John in there accordingly, only with the 2nd and 4th column. Now in your assignment, you're going to be doing something very similar where you're going to be looking for particular files or components within files that have a particular, say, string of characters in there. With sort, what you can do is that it's as easy as what it sounds. You have a particular set of words in a text file or whatever the case may be. You can go ahead and sort them accordingly. So right here we have eyes, record, explosive, spice, prison, so on and so forth, right? Sort will actually go ahead and sort them into the alphabetical list that you can see. So that's pretty straightforward. What we can also do is that we can also sort based off of numbers. So we can sort, say if we wanted to do the sort function, right? What we needed to do if we wanted to do it with numeric data instead of just just the text information, we can go ahead and sort, and we put in the flag -n, and that'll sort all of the numbers within this file. Unique removes the duplicate lines from a text file. So unique only searches adjacent lines to find duplicates. So the input must be sorted first. So what you want to do, if you want to remove duplicate values from a particular list, say that you're doing like user management, for example, and then you see 4 users with the same username and email address and so on. You want to go ahead and remove it, and you want to have only one record of it accordingly. So you go ahead and sort that entire list, and then what you can do is that you can start to remove the duplicates accordingly. So you can see apple, banana, orange, orange. This is a list that's already been, that has some sort of sorting in there. Now you want to go ahead and actually sort it. So you want to make sure that you sort this accordingly. And then you run the unique operator. So instead of running 2 commands, you can do 1 line, sort this particular list, and then pull out only the unique words within it. To substitute X, Y, and Z for all occurrences in A, B, and C in a text file, what you can do is you can actually go ahead and run that accordingly. So say that we have this particular text file, original.txt, and the file has this particular phrase in there: the quick brown fox jumps over the lazy dog. You can replace all of the letters A, B, and C with X, Y, and Z. So it'll actually go ahead and replace all of those characters accordingly. And you can see that as needed. So a more commonly used function for TR is to convert the lowercase text into uppercase and vice versa. So some programs, they require only uppercase or only lowercase values as input. And if you try to send in the opposite, what will happen is that the program will fail. So what you want to do is that you want to go ahead and run this particular command, cat, the particular file that you're looking at, pipe tr, and you want to change from lower to upper accordingly. So these are character sets. So the bracket colon lower colon bracket and colon, or bracket colon upper colon bracket are character sets. So it's a quick way to specify the lower and uppercase letters respectively. So then you can go ahead and look at the entire manual page for a full list of available character sets that are available to you. So what we've got here is that we can now go ahead and manipulate the text within files. So now we know how to go ahead and run a basic script, different commands within it, right? And then we can go ahead and start to manipulate text within files as well. The next thing that we want to look at is what's called variables. And variables give you a significant amount of power in running scripts. So a variable is a representation of a piece of data stored in computer memory. So it's a number, file name, text string, etc. So to create a new variable, simply supply the variable name and the data it represents, the value. So an example right here, right? My variable is equal to 20. And if you echo, which is basically printing it, right, which is showing it on the console, the variable, the $ my variable, it'll bring out 20. Now, why do you want to use variables? Variables are very, very important within programming because it gives you the ability to have a particular value or particular representation of data that you can call repeatedly. So throughout the course of a particular script, what you can do is that you can keep calling my variable instead of typing in 20, 20, 20, 20, 20, 20 throughout the entire script. Where that becomes particularly useful is that, say if you want to update a script. So you saw that in previous assignments, you had to actually update the wait time from, I think it was 22 hours to 300 seconds or something like that. You only have to update that particular variable accordingly. You don't have to repeatedly put in 300 over and over and over and over again across multitude of scripts. You just update it in one place, and then in that one place it will go ahead and show up everywhere else that that variable is called. And you don't want to have any spaces before or after the equal sign when assigning a value. So following assignments will result in errors. So my variable is space equal to space 20 is not going to work. Neither is my variable space equal to 20 or my variable equals space 20. It has to be typed in my variable is equal to 20. Now, this particular my variable, you can go ahead and call it whatever variable. It can be X, it can be Y, it can be Z, it can be whatever, right? There are some naming conventions that change from programming language to programming language, but in general, you can go ahead and name it something that's descriptive of that particular variable. So if this 20 was actually the wait time that you wanted to have, right, you may call that variable wait time. So you can also assign text as a variable's value or even another variable. So hello can be equal to hello world. So every time that you echo hello, it will actually show you hello world. And you can also assign hello, this particular variable, to another variable called world. And you can echo world and it'll show you hello world because that is actually assigned to hello and hello is assigned to hello world. So variables are actually a very common programming tool that you can use to store a particular piece of data that you can keep calling again and again throughout your script. If we continue with variables, there's also what's called a command expansion. You can assign the output of a command as the value of a variable. So you can enclose the command in $ parentheses. So for example, this particular date, if you say date in that particular in the command line, it'll give you what the date is that's currently on your machine. Now you can go ahead and assign the date to a particular variable and echo that particular variable, and it'll show you that that situation, or what that command would show you at that point in time. Now, where would something like this become useful? Say that you have a script, and the script is supposed to run at a particular time every day. So what you can do is that in that particular script, you can specify now is equal to $ parentheses date, and if now is equal to 5 p.m., conduct this backup, right? So that we're getting a little bit into conditionals now, so if statements. But if it equals this particular date, then we can go ahead and execute accordingly. And it'll automatically run at 5 p.m. every day. This is very useful in the concept of backups. You want to do backups at a certain time every day, right? Well, how do you do that? You can actually automate that. You don't have to manually do it. You can make sure that that backup occurs accordingly. Similarly, if you wanted to do access management, for example, right? You run that particular script on August 8th every single day or every single year, so that it will go ahead and update the users, the new users, and remove the old users accordingly. With variables, you want to think also about what's called basic integer arithmetic. So if you wanted to do my variable is equal to 20, my big variable can be equal to $ parentheses parentheses $my variable times 100. And what these parentheses do is they're basically the syntax that you need to use when you're using when you're doing bash scripting. So you want to go ahead and echo my big variable, and this will return the value of my big variable. So we went ahead and multiplied 20 times 100, we got 2,000. And say that we wanted to actually do my big variable plus 1, we can do my big variable plus 1, and that'll give us 2001. So we can go ahead and start to do basic arithmetic in this fashion. We can also do what's called quoting. So if we wanted to write a basic script, so the idea is to enclose a variable in single quotes, it causes the variable name to be used literally. So instead of just using that variable name in a particular task, we can just use that particular variable in a naming convention. We can go ahead and run a script that looks something like this. So remember, we have the hash, pound, shebang, space, /bin, /bash, and we got the name is equal to Alice. We can go ahead and echo this particular thing, so it'll print it. My name is the variable name, so the variable name is actually going to be Alice, right? I'm sorry, it's going to be the Alice right here, and then the date is this particular date. Well, what you can also do is echo the one with a single quote, and what you're going to get is that you're going to get, if you were to run this particular script, since we have the bin bash up here, we don't have to actually call the bash. We'll see that the first line of the output that's related to echo this first line is going to be my name is Alice and the date is 12/19/2012, and then the second one is going to be my name is $name and the date is this particular variable name. So if you have the single quotes, it will actually go ahead and call the variable name literally. So it will literally be what you said it is. Where if it's a double quote, what will happen is that you can go ahead and call that particular variable accordingly. So the single quotes in the second line printed literal variable names. So these are the actual variables that you have put together. And the variable substitution is on the first string. The current date was substituted for the date plus %m/ and so on and so forth, without the need to assign a variable name. And the commands enclosed in the $ parentheses are run each time they're encountered in a script, and the value is determined dynamically. So that's the concept of what's called variables within scripts. Now we can also do what's called environment variables, and these variables are created automatically on login or starting a new terminal window. And they are the default values and user preferences for the current terminal session. So the other variables, we can go ahead and start to assign particular pieces of data to it so that we can call it later on in a particular script and start to perform certain tasks like arithmetic, or start the foundation for regular recurring tasks or things like that. Now, with the environment variable, you view it with the env command. So if you're Alice at Sunshine, and you're in the prompt, you can go ahead and type in env, and what it'll bring up is a list of different properties associated with that particular account. So the host name is sunshine.edu, the shell is bin/bash, the user is Alice, and you can get a lot of different types of information out of that particular env command. Now, the environment variables can be very useful in shell scripts. So the environment variables can be used in shell scripts and commands just like regular variables. So it's created automatically by the bash interpreter. And it's a dynamic output on the user executing the command or the script. So if we were to go ahead and type into the terminal, echo, my name is $user and my current directory is $print working directory pwd. Well, what will come out is my name is Alice and my current directory is /home/Alice. Now, if you were to go ahead and open up a script and start a new script, and the script's name is env_variable_example, and you have the shebang /bin/bash, so you don't actually have to call bash each time, what you can do is call hello user, or the variable for user, echo, you're calling this program from print working directory, the variable, and your home directory is home. What will happen when Alice runs this particular script is that you can go ahead and see, hello Alice, you're calling this program from this particular location, the print working directory, and your home directory is this directory. So what you can see up here is that the environment variable will actually give you all of that information. It'll be the user, the print working directory, and so on and so forth. And you can actually go ahead and call this information from a particular shell script. So this will give you the ability to start to customize certain types of scripts for different types of users. So when Bob runs a particular script, what he will see is, hello Bob, you're calling this program from /temp. Your home directory is /home/Bob. So this gives you the flexibility, instead of having to print out this information manually each time for each user, what will happen is that you can actually go ahead and provide that information automatically to each of the users accordingly. Now, where does this become useful for a systems administrator in a particular InfoSec situation? User management, access control. You know, we keep going back to that particular example where if we wanted to provide particular permissions or particular resources or different types of information to different types of users, you can actually use these types of environment variables to provide these types of high-level information or specific permissions to particular users. So every time a new user logs into a machine and they're part of a particular group, what you can do is you can give them the information that they're only allowed to see. So that's with environment variables. So there's basic variables, environment variables. There's also what's called built-in variables. And these are several variables with useful values. This is in addition to the environment variables that are provided. They're collectively referred to as what's called built-in variables, and they provide a wide array of small functions. So reporting the type of hardware the server is running, returning the status of the last command issued, and dozens of built-in variables to choose from. Here's an example script. So right here, what we've got is the shebang /bin/bash, so you don't have to call bash each time from the terminal. Echo, this script is executing with process ID. So this is a built-in variable right here. Echo, the OS type, and then the hardware, the machine type. And you can see all of the different types of built-in variables that are available. So you can go ahead and get the date. Echo, the exit value from the date was this. This is the command should fail here, and start to run other commands as well. So the output from this is that this script is executing with a process ID of this one. The OS is Linux GNU, the hardware is this, and so on and so forth. So you can actually get all of that particular, all of those built-in variables accordingly. So other built-in variables include random. So if you wanted to go ahead and include random information or random numbers and so on, you can echo different things. So you can start to see how all of the concepts that we've talked about in terms of starting up a script, having different commands in that particular script, and then being able to call different types of variables, such as environment variables, variables that we ourselves have defined for particular values, and then being able to actually call the built-in variables can start to give you a lot of information, not only about the particular machine that you're on, but also about the users that are running it, and so on and so forth. Now, so that's really on the command side. So we've gone through a lot of different commands now of how can you execute certain tasks. You can remove files, you can change directories, you can print working directory, you can define variables. Variables will give you the ability to be called from different locations. You can print information to the console. You can execute certain tasks at given times. You can assign values, and so on and so forth. Now, one of the key techniques that you're going to use is conditionals. And conditionals are very powerful. So there are a lot of situations within a business environment. You're going to have situations where it's going to be if this particular person or if the situation matches a particular condition that we've set, so hence conditional, we can go ahead and perform a particular task. So it's like any other programming language. If or then. If it pertains to a particular situation, then do this. If it pertains to a particular situation, then do this. If it doesn't, then do something else. And then so on and so forth. So if it does this, then do that, and then else if it doesn't, do this instead. So an example, again, we've got the shebang /bin/bash. If the user is equal to Alice, then go ahead and print echo good morning Alice. So oftentimes in other programming languages, say PHP, if you log into a particular website, what will happen is that it will say, what will happen on the back end is if the username is equal to Alice, then go ahead and echo on the screen in the top right hand corner, good morning Alice. And in this particular system, it's good morning Alice right here. So let's go ahead and go through an example script. What we're doing here, we're going to merge some of the concepts. So we've got the shebang /bin/bash, so we don't have to type in bash at the beginning of the command or beginning of the call. If get, so we go ahead and assign a value to guess called number 2. And then what we do is we assign another variable called number, and we assign it a random number. So we're going ahead and using some of those built-in variables that are provided in the Unix system. Mod 100, so we're merging some of the concepts we've learned about in previous lectures, plus 1, that's going to be assigned to a particular number. So what we're going to be doing is we're going to be trying to guess if the number is correct. If the guess, which is number 2, is equal to the number which has been randomly generated, then we're going to print out correct guess. The number is, then you print out the particular number. And since it's in double quotes, what will happen is that that exact number will be printed out. Otherwise, if it doesn't, is the guess high? If the number is less than or greater than that particular guess, then the guess is lower. Then print out the guess is lower. The number is less than the guess. Is the guess low? If the number is greater than the guess, then echo guess higher. The number is greater than the guess. So print out that particular feedback. So essentially what this script is doing is that you have a guess, you're putting in a guess, right? And this guess you have to put into that particular script, and it'll generate a random number. If the guess is equal to that number, then be like, hey, you've guessed the right number, and this is what the number is. If it's not, then it will say that, hey, your guess is, if it's too high, if it's lower than what the random number is, then go ahead and print that out. Tell the user that this is less than. If the guess is higher, then go ahead and tell the user that it's higher accordingly. And so if you were to run this in the terminal, what you'll see is that, so again, you don't have to run bash, but opt/book/chapter11/number guess v2, which is what the script is, it will actually print out the number is greater than 2. So it generated a particular number, ran it through this arithmetic function, and then it compared the guess. And since the guess was not equal to the number and it was lower, it will not print out these two statements right here. Instead, it will go into this third one and it'll print out the number is greater than the guess. So some of the gotchas that you may actually run into for your assignment that often get many programmers all across the world is, you got to make sure that the appropriate syntax is in place. So there's a mandatory space between the if and the square brackets, and around the comparison statement inside the brackets. So most other languages are forgiving in their use of white space. So like Python, you can, white space is going to be a little bit more forgiving there for these types of situations. Any of these attempts in an if statement will fail with an error. So if you have a space, if you have a particular script that you're putting together for your assignment and it's not working, and it's showing some sort of an error, take a look at your spacing in there. So the if in these particular the spacing in these if statements are not all where they should be, and there's different operators for different data types. So for string comparison, so if you're comparing text with text, right? So if it's a user, right, and you're comparing it to Alice right here, right? So these are text, you're going to do the equal sign. If it's a numerical comparison, so 2 equal to 2 or whatever, right, you're going to be doing the -EQ. Now, what we've seen so far is that everything we've done is looking inside of the script itself. Right, so we've developed a script, and at the beginning we talked about scripts that we can go ahead and start to, run a backup every day, right? And we can specify the backup at a manually specified time. We have to go into the script and we can put in a particular time and when we want to do the backup and so on. In this particular script, we're doing the guess that is within the script itself. So you actually have to open up the file and then change this variable in order for the program to start to run in different scenarios. So our guess may not always be 2. But say that we didn't actually want to open up the file, because that could be very cumbersome, right? We didn't want to actually open up the number _guess _v2. What we wanted to do is actually have a mechanism where we can specify what our guess is in the command line itself, and then the program will spit out the particular output. This is where something like user input will come into play. So how do we accept user input? So again, so far we've created variable values within the script. But what if you want values that are supplied by the user themselves? And there's 2 ways to accept input from the user. There's what's called command line arguments, and these are like other command arguments that we've used so far. So automatically stored in special variables when the program executes, and the variables named in order entered on the command line. And then there's the read command, pauses execution of the script. So until the user enters a value for the variable and presses return. So I'll show you examples of both. So command line arguments, say that we have this particular script right here. Again, shebang /bin /bash, echo, the first argument is $$1, the second argument is $$2, and the third argument is $$3. If we go ahead and put in OPT, we access that particular file, we can actually put in the values that we want for each of those variables. Now this becomes very useful, because what we can do is that instead of having to open up that particular file, we can go ahead and specify in the order that we want the variables to be inputted from the command line itself. Now you can imagine once you do something like this, you can actually pipe it into other scripts as well. You can start to cut, you can get the sorting, and so on and so forth. So the first argument is going to be 42 because we put in 42 in the command line right here. The second argument is going to be hello world because that's the second variable we put in. The third argument is earth. We go ahead and put that here, and that will actually show itself in the output from this particular script. So notice that the second argument consists of 2 words, hello world. The quotation marks around the group of words tell Bash that this is a single argument. So you want to make sure that you are putting in the appropriate amount of arguments into the script. So for example, what you may see is a script that looks something like this. The shebang /bin /bash if $hash equal to 3. So we're going ahead and taking a look at whether or not this particular number that we're providing in is equal to the number 3. Then the first statement is equal to this particular value. Else the three arguments are required. So if we put in this particular script, the file name of the script, and then 42 and earth, what will be the error that's going to come back is 3 arguments are required. It's actually looking for 3 arguments. It's looking for 3 different commands or 3 different inputs. So that's in terms of the command line arguments. You go ahead and put in the command line, exactly what arguments you want the script to take in. Now with read command operators, what you can do is that you can actually read a particular command that a user has provided as input. So you want to prompt the user for input. So let's give you an example. We got the shebang/bin/bash, and then the comment here is that we're going to prompt a user for input. And this is not something that's going to be running, the prompt for user for input. Instead, what we're going to do is we're going to print this out onto the screen, enter a number between 1 and 100, and press enter. And then what will happen is that it will read the guess from the particular user. Then what will happen is that the number is going to be assigned. There's going to be a number that's assigned to a particular random number that's mod 100 plus 1. And then it will see if the number is equal to the number that was provided from the user. Then it will execute the rest of the script. So again, if it's higher or if it's lower, it'll print out an appropriate response to that. So there is the script that we're running, and then what will happen is that the user will actually get a prompt saying that enter a number between 1 and 100 and press enter. So it'll be, you can type in 15, and then the script will pop out, guess lower, the number is lower than 15. So that's with taking in input. So we can go ahead and start to read commands. We can go ahead and also put in command line arguments as well. And that just gives you an additional level of customization and an additional level of convenience that you can have when you're executing particular tasks for a particular script. And where this has become useful, say if you're doing like user authentication, this could be enter a user's name, for example. And then that user's name will be put in as input into the script, and then it will go ahead and execute. Say if we want to make sure that a user is part of a larger user list, for example. We can go ahead and put in a user's name and then see if it actually is a part of that particular user list. Now loops, so those were conditional statements that we talked about before, and then also the reading in commands and that type of thing. Loops are a central feature of programming languages, and what it does, it's great for automation. I mean, every programmer will use loops in some way, shape, or form to help automate tasks. And it's a central feature of all programming languages. It reduces repetitive tasks into a few simple commands. So instead of typing the same or similar commands over and over and over again, a loop will actually repeat a set of commands. So there's different types of loops, and there's 2 types of loops that we'll talk about. There are for loops and while loops. A for loop is a basic looping construct. So it repeats commands using a given list of input items. So for every item in a list, or every item in a shopping bag, do this particular task. The interpreter jumps back to the beginning of the loop when it reaches the keyword done, and it begins the next iteration. I'll show you examples of this. And during each successive pass, the value of the loop variable changes to the current element in the list. And I'll show you examples of what this means. And then while loops, it repeats commands while a given condition is true. So while a particular number is lower than 100, then go ahead and print out a particular output. So a for loop, the first example that I'll show you. For a variable in item 1, item 2, item 3. So this is the particular list that we're looking at. Do this particular command. Echo the current item is this particular variable. So what's happening is that you can actually go ahead and for the variable in this list, so what will happen is that it will print out that particular variable in the list. And then when you actually call it, the current item is item 1, so it's printing out this. The current item is item 2, it's printing out item 2. The current item is item 3. So note that the value of the $var changes in every iteration because it goes ahead and assigns a particular value to the variable and then performs a particular task on it. In this case, it's just printing it out. But you can do other things such as changing it from all uppercase to lowercase, for example, or adding in .edu to the end of everything, and so on. Another example is that for Word in a particular text file, do this particular task right here. So you can echo the original word right here and then assign it, put in that word. So there'll be multiple words in this particular text file, so you can go ahead and print it out. Then what you can do is that you can echo all uppercase, and it'll go ahead and make sure that all of the words that were lowercase are going to be uppercase. So if you run this for this particular script, what's going to happen is that the original word is eyes, and it'll print out eyes right first. Then it will print out all uppercase. Then the next original word is record, and it'll print out all uppercase. And the next original word is explosive, and then all uppercase for explosive. And note that the output of the command used is as the list of items to iterate over. So you go ahead and iterate through all of the items in that particular list. In this case, it's a list of words. There are also what are called internal field separators, or parentheses $IFS. So $IFS is a new item in a loop is created when the $IFS list is found. So the default values are white space characters, space, tab, and new line. So if you take a look at a particular example, for line in this particular list, go ahead and print out that line. So what we can see the output for this particular script is as such. And with IFS, if we continue to look at IFS, the previous output is used as default value for IFS. So the lines from the etc/password are broken up into in the middle of the fifth column, and this is due to the space or spaces within the text of that field. To fix this, we can set the IFS to contain only the new line character, $/n. So in this particular situation, what we can do is that we can change the IFS to the new line character only. So we can set the IFS to the new line, so it's actually getting a new line. For the line in each of this, in this particular file, do this particular task, which is echo the line. And you can see how this output comes out accordingly. And one thing to note is that the backslash in the output above is a line continuation character. It's used because the output is too long to fit in a single line. So actually what happens is that this particular output is much longer. It's not multiple lines that's coming back. It's actually one long line, but it's breaking it up accordingly. Now we can also look at what's called sequences, and this is the common need for counters and loop outputs. So it's included since the Bash version 3.0, and number sequences are around curly braces, and the arguments are separated by 2 periods. The sequences are created using 2 or 3 arguments. If 2 arguments are given, the first value is the starting value, and the second value is the ending value, and increment by 1. So for the numbers in this particular list between 1 and 5, do this particular task, echo the number. So we want to print out that particular number. So what will happen when you call this script is it's going to print out every single item in that list. In this case, it would be 1, 2, 3, 4, 5. So you can actually go ahead and say 1 to 100, for example, and then just print that out accordingly with this particular for loop. You can also increment numbers backwards. So for the number 5 to 1, right, you can go ahead and echo the numbers 5, 4, 3, 2, 1. Now, you can also think about users in a particular user list. So if we think about all of the other commands that we've had, we can go ahead and cut a particular column from a CSV. Then we can sort that column. And then what we can do is that we can print out that column iteratively. So we can go down every single person in that list and print it out accordingly. Or we can go ahead and attach a .edu to it or something of that nature. If 3 arguments are given, then we can go ahead and the third argument is the increment. So you need to make sure that you have bash version 4.0 and so on. So for number in 1 to 10, increment by 2. So what will happen is that it will start off by 1 and then add 2 each time until it gets to the end. Sometimes you need to stop processing in a loop. So break is where you want to break the loop. So it skips any remaining commands in the current iteration of the loop and skips all remaining items in the input list. The script continues to execute any commands after the loop. So we've got a for loop right here, right? Within that for loop, we can actually put in an if statement, for example. For the numbers between 1 and 5, do this particular task. If the number is equal to 4, then echo stop and break the loop. So we won't go any further. Then go ahead and print out the number, and then it's done. So this command runs after the loop is complete. So you can think about, it's printing out 1, 2, 3, then number 4 is what it's equal to. Then we want to stop. Then this command runs after the loop is complete. We go ahead and print that out accordingly. So we can actually break the loop after we met a particular condition. We can also do what's called continue. Skips the remaining commands in the current iteration of the loop and begins the next iteration. So the example below replaces the break keyword in the previous example with continue. So for the number in between 1 and 5, do this particular command. If the number is equal to 4, then echo stop and then continue. And then echo the number done, and then echo this command runs after the loop is complete. So if we were to actually run it, it's going to be 1, 2, 3, echo that particular, echo stop because we've got number 4, but we continue the loop. And then the command runs after the loop is complete. That gets printed out. So that's with a for loop. A while loop, which is the second type of loop that we'll look at, is it continues running until a specific condition is met. So instead of operating on a list of items like a for loop, the condition is tested before starting the iteration of a loop. If the result is true, then the commands inside the loop are executed. If the result is false, then the loop is skipped and the rest of the script is executed. So we got the shebang /bin/bash, then we got the counter is equal to 1. While the counter is less than 5, then do this particular task. Print out the counter and then add 1 to that counter. So we've got counter, which is a variable, equal to counter, which is the current value of counter, plus 1, and then done. So it'll continue to go back through this. So while the value of counter is less than 1, then or less than 5, go ahead and run this loop. Now what happens is that the output is going to look something like this, and you can again set the counter to be a variable, and you can call that from outside with the user input and so on. Now we also have the concept of what's called infinite loops, and it's needed when you want an operation to repeat until the user explicitly ends the script. And I'll give you a fun story about infinite loops in a second. Typically used when you want to monitor something at regular intervals. So for example, the size of a file, number of logged in users, and so on. So you want to create a while loop whose test condition is always values to true. So you want to make sure that it will always be true. So you don't have something equal to 5 and it's incrementing or something like that. And example uses of infinite loops to monitor the size of a log file. So you want to go ahead and create a log file, and with each iteration, the time the file was checked and the size of the log file is printed to the screen. And you end the script by printing Control-C together or closing the terminal window. So it's really good for monitoring the size of files on your network, for example. So you have this particular script. Echo, the script will loop forever. Hit Control-C to exit. While this is true, do sleep 2, echo this, date, and then the echo right here, done. And this script will run forever until you press Control-C. To test the script, you start the script and then you open the web browser and you see the number of log files will increase each time you load the web page. So this script will run forever. Hit Control-C to exit. So you can actually go ahead and do this in your VM and see how this particular script will continue to show you the size of the file based off of how many times you access sunshine.edu. Now, a fun story that I want to give you guys is that I was actually at the 2015 penetration testing Black Hat training at the Black Hat conference. And what they told me is that you can actually use infinite scripts not only to do something like this, but you can actually use infinite scripts in the context of, say, breaking into a system, brute forcing, for example. You can set up an infinite script that will brute force particular systems. And there was a MySQL database that one of the lead pen testers, Dave Kennedy, had talked about. And he said that what you can do is that you can actually set up an infinite loop that will actually test values, usernames and passwords infinitely, the same username and password over and over again. And at a certain point, after 10,000 attempts, what will happen is that MySQL will actually give you automatic access into the system, whether or not the username and password was correct. So you can use infinite loops in that particular context. Say if you increase the value to 100,000 username and password attempts before it gives you access, you can set up an infinite loop so that no matter what the number is, it will actually be able to get to that number and get into the system. So he said that that was one of the easiest hacks that he's ever done. So now we've seen all of the different types of script constructs. We've talked about variables, we've talked about different commands, we've talked about loops, we've talked about conditionals, and so on. And doing anything useful usually means that you have to combine these constructs in meaningful ways. So example displays useful information in all user accounts in the system. So reads lines from a particular file, it parses the line contents for useful fields, skips system accounts, and then displays the useful fields in line. You can actually try building scripts like this that merge different concepts together. And one of the key pieces of advice that I'll give you is that whenever you're starting up a new script, have a particular purpose in mind for that particular script. So you don't want to just start writing scripts and then, I'm not exactly sure what I'm doing with the script, or the script keeps going on and on and on and on. Have a particular purpose for it, and make sure that the scripts are relatively short and they perform a particular task. So let's go ahead and put it together. So for the user in this particular file, and we're actually cutting out the first field, do this. So we're going to add in a new line, and we're going to go ahead and start to assign variables. So the home is equal to the user info, and we're cutting from that file, and we're going to go ahead and start to skip those users that don't have home in their path to their home directory. So if the home does not, or if it fits this particular condition, then continue. Print out the username, print out their disk usage, and then go ahead and start to assign additional variables to them. And then you can start to print out when their last login was and so on. So you can start to see how this becomes very useful. So if we run this script, we can get the information of Alice, their user information, their home directory, the groups that they're associated with, their disk usage, when their last login is, and so on. Similarly, if we were to run this for Bob, we can get all of this information for Bob as well. So this is really an example of a script of putting all of these components together. You're cutting from particular files. You're starting to skip over particular files or lines that don't meet certain criteria. You're looping over multiple users, and then you're also going ahead and printing out those particular pieces of information that are very useful for you as a systems administrator. Now remember, you can start to do this for multiple tasks across an organization. You can start to update software across an organization for multiple users across thousands of machines and so on. You can perform a lot of those controls that we talked about. Access management. You can parse through thousands of log files that are generated from intrusion detection, intrusion prevention systems. You can do password management, for example. Say there's a policy that's been put down from upper management saying that, hey, passwords have to meet this particular criteria. Then what you can do is that you can write a script and then go through all the usernames and passwords that you stored, then hopefully they're hashed, unhash them, and so on, and make sure that they meet that particular criteria. So you can see how all of these concepts are merging together to develop a really robust mechanism to help you implement the appropriate controls that are necessary within your organization such that you can maintain the confidentiality, integrity, and availability of the particular information assets that you're looking to protect. So again, this is a lot of concepts that I talked about in this particular lecture. It can be really overwhelming. I really urge you to take a look at the review questions at the end of chapter 10 to get a more robust understanding of the different types of commands within shell scripting and more importantly, the role that they play within setting up the appropriate controls or performing systems administration tasks to ensure the best cybersecurity posture that you can maintain for your particular organization. As always, please feel free to reach out if you have any questions. Thanks.